title of Mr. Klaus's presentation is The Rise of Cognitive Secrecy. It's a difficult word. Thank you. Welcome.
Hello, everyone. It's good to be with you. Thanks to the organizers for inviting me here. My goal here is to talk to you a little bit about cities as technology and some of the convergence that we're seeing at IBM and with our customers around bringing Internet of Things together with cognition. And this is such a big piece of our business for IBM that I actually work for a division called Watson IoT. And so that's trying to bring IBM's cognitive technology together with our Internet of Things technology and apply it to many things. And I'm here to talk to you about cities. So since 2010, I've been working on smarter cities for IBM. And what we've seen is a lot of application of what we call Internet of Things. We're gathering data from sensors, from people, from telephone calls, from call centers, whatever it might be. And we're doing things with that data. And now what we see is a real convergence towards applying cognition, artificial intelligence, and machine learning to that data, and moving beyond an Internet of Things into an Internet of Events. And so that's what I'm here to talk to you about today. So Douglas Adams, who wrote The Hitchhiker's Guide to the Galaxy, said that anything that's been invented when I'm born, it's part of the real world. So you see this, children 3 or 4 years old, they go up to a computer and they use it in a way that we never would have thought they would. Anything that's invented from the time I'm born until the time I'm 30 is really exciting. This is a place where I want to make my career. This is technology I really want to apply. And then everything that gets invented thereafter is just a threat to life on the planet. Until it's been around for 10 years, people resist. And I think we see a lot of this sort of orientation towards technology. And it's something that we all need to, we all throughout our lives need to stay in bucket number 2 and not view all technology that appears as evil. Because at the base, we humans are technology users. We're tool builders and tool users. And tools aren't simple things, they're complicated things. They can be things like buildings, things like things that we do to augment our capabilities and our personality. And my statement to you is that these things happen very quickly. It wasn't so long ago that these first smartphones came out, and yet today, all of us, or most of us, carry around these smartphones. And a visitor from Mars would think that these telephones are part of who we are. They're part of our anatomy. If you are on public transport these days, I challenge you to watch the other passengers and see how many of them are face down looking at their device or in a conversation with somebody not on the public transport that they're on, but somebody at a distance. So these technologies pervade our lives, and they become crucial to the way we deal with the world. And we can also think of the entire city as in this way, that the entire city is really a technology that is the means for us to interact with the real world. It's the services, it's the contracts, it's the understandings that let us carry on a day-to-day life that is much richer than we could have 50 or 100 years ago. And these contracts, these agreements, these standards are very, very important to the quality of life. And I know all of you as city leaders want to make sure that your city is the place where people want to live, they want to work, and they want to raise their families. And so understanding the quality of service that you can deliver to your citizens and constantly improve that will be the key to success. So really what we want to focus on is how can we design more empathy into cities? How can we make cities more responsive to the needs of citizens and to the needs of people like emergency workers, police officers, firemen, etc., so that we can have a safer, more human city that corresponds to the needs of our citizens. So what I'm here to talk to you about is Watson. It's our technology for doing cognitive computing. And what I want to talk about is how do we apply that futuristic capability that's here today. How do we apply that to life in the city? So first of all, cognitive computing is really an overall effort to have computers understand, reason, learn, and interact. So our goal here is that computers can increasingly understand things like images, things like video streams, things like calls into a call center, things like data as it comes in from sensors. And so first and foremost, what we want to do is help the computer to understand. And we want it to understand in context. We want it to know that this camera is related to this bus, or this police officer is in this location. So understanding things and correlating things is vital. So there's a level of recognition and then correlation. The second thing that we want the computers to be able to do, and that they are doing today in cities, is reasoning. We want them to formulate hypotheses and then test those hypotheses. And in this way, continuously learn. I understand the traffic pattern of a city better than I did yesterday, and tomorrow I will understand it even better because I'm learning over time as a computer. And last but not least, really most importantly, we want to have computers and humans interact. This isn't about having the computers take over processes. This is about having humans and computers collaborate and work together in a process to find problems and resolve them. And that's really the work that we're up to. Now, the Watson technology does these things for all sorts of domain areas, but for me, I find them particularly interesting to apply these to cities. And I'd say the first thing that you should all know, and you hear this all the time, is no data, no AI. So machine learning, all the rest of this cognitive technology really thrives and works because of big data, because we push a lot of data to that artificial intelligence, and that artificial intelligence can therefore learn faster and grow skills. So what we then can apply to all that big data is a lot of different algorithms, a lot of different ways to think about information. And so each of these represents a set of tools that software developers can pick up and use to understand data in context. The wonderful things about cities is that cities generate a large amount of data, right? You've already been instrumenting your cities with speed sensors and with weather sensors and with police activity sensors, et cetera. So your city's already generating a lot of data, and it's getting teams of people, citizens or employees of the city, to build software around these style of activities. And so I'll talk to you about a few of those activities. Again, the city's generating a large amount of data about the locations in the city, but also I would advocate that you don't underestimate the importance of social networks. Citizens are generating a large volume of data in tweets and in other social media interactions. And harvesting that data is now very, very possible. And really smart applications are going on where we understand citizen sentiment. Do they like the way the new tram works? Do they like the way the new park is? Are the potholes being repaired, or are people complaining? Do they like the traffic or do they hate the traffic? All these things can now be sifted and understood in a very automatic way. And so I would encourage you to not underestimate the importance of social media. So a trend that we see in general in the Internet of Things is that people want to create what's called the digital twin. And this I think is a very important understanding about where the Internet of Things is going. And that is, now that I've put sensors onto my device, whatever my device is, and I'll come to a few examples. Once I put all these sensors in, how do I make sense of all that sensor data? And how do I let people interact with it? And the answer emergingly seems to be that we create a digital twin. If something is important enough for me that I care about it in the real world, and I've instrumented it in the real world, then what I should do is create in silico, inside a computer, a digital copy of that thing. So I know the temperature, the pressure, whatever aspects that I care about that thing. And that digital twin is a computer twin, an in-computer twin of a physical object in the real world. So at IBM, we work with companies like Schaeffler and Airbus on their digital twin technology. So for every airplane that Airbus flies, they keep a representation inside a computer of the fuel level, the speed, the location, all the data that they're gathering off of that plane. And with this digital twin, they have a permanent record that they can go back in any time, understand the state of that plane, understand the state of its repair, et cetera, et cetera. For high-speed trains, Schaeffler's doing the same sort of thing. And what we're trying to do with our customers and our partners is apply this same concept to cities. If I care enough about a bus on a street that I've put cameras in it and I've instrumented two-way communication with the driver and I put sensors on the bus, then somewhere in a computer or in multiple computers inside my control center, I should be able to inspect that bus at a distance. So this notion, if I go back just one, is that we want to remotely understand the status, history, and needs so that we can interact with it, so that we can do work with it, so that we can make its service better, make its life longer, make its capacity better. So that's the digital twin concept, and I think it's something that's worth keeping in mind as you do more work with Internet of Things. So at IBM, we create, and I'm sure many of you also do this, we create dashboards for people who work in the city. This one we did in our center in Nice and Paris. And this is really sort of a mayor's dashboard at a mayor's level. What does the mayor care about? Emergency management, transportation, water, et cetera. So at a high level, we care about sort of the ongoing status of things, and then maybe some key elements of important activities going on in the city right now. But for us, we believe that every time we look at the city, we need the capacity to really drill down. So some of our employees don't care about the entire state of the city. They care only about the transportation state of the city. So there should be, if I click on transportation, there should be a whole nother layer that just is about public transportation. And some of our employees, they only care about public transportation. They don't care about the traffic on the roads or other transportation. So at every level, we can continue to drill down and get more and more information. So I'm sure many of you are building these sorts of dashboards for your cities. And what we'd like to do is say, dashboards are good, dashboards are great, but we're going to need to collectively go well beyond dashboards. And that's where the application of the cognitive technology, I believe, will help us. So we work with Veolia. We started this partnership about a little over a year ago to create a joint product. So our developers and Veolia's developers work together. We jointly build a product, and then we take that product to market. And we're finding this is a good model. This is a model that we want to repeat. Take some subject matter expert who's really, really strong in the city domain and collaboratively develop a product. We find that resulting product is much better than what we can do on our own. And so we're going to keep repeating this. So we created a product that's very, very focused on water management, fresh water distribution, sewage, all the aspects related to water. And again, we jointly sell this product, and it's here we're in a center in Lyon, France. We have a series of water operators who are using this software to understand the state of the water network, and they get alerts when things go wrong. And I think that the really important thing to do is, what do we do when things go wrong, right? So increasingly, these operators know, and increasingly computers know, when something goes wrong. And so one of the real focuses is on very precise notion of how do we deal with a crisis, how do we deal with an issue when that issue happens, and that is really a joint effort between man and machines. So basically what we're doing within our group is we're helping leaders to manage cognitive cities. We're doing this by helping them put their city and the objects that make up their city, their assets, their sensors, their workers, onto a map and understand the process that is going on in the city to automatically identify incidents and respond to them. And this is sort of very key to reactive governance. And then be able to have computer analytics and human intuition meld together to solve these problems. So first and foremost, we have the notion of these key performance indicators, these ideas about how is traffic doing, how is public safety doing, how's water doing. But then the really important thing that I think a lot of us need to start really working on is standard operating procedures. When one of my issues goes red, when one of my key performance indicators goes red, how do I have man and machines cooperate to solve the problem? Who do I need to call? How do I need to get hold of them? What do I need to do if they don't respond? Who's backup, et cetera? And by codifying these things, we have a standard stepwise way to resolve problems quickly and to keep the officials involved informed, right? So often what happens is we have some sort of crisis in the city and the mayor wants a constant update, right? Where are we? What's the process? Who's fixing what, et cetera? So these standard operating procedures not only help to organize the response, but they also help to communicate the response. So again, I think that as we do more and more work in the space, this notion of a set of things that can go wrong and what do we do if they do go wrong, that set of thinking through that and codifying that can really, really help. Okay, so I think that a lot of people sort of, as Adam said in the beginning, a lot of people sort of worry a lot about the future of machine intelligence and deep learning and cognitive computing. And I guess I want to make sure that you understand that our goal here is really to make men and machine cooperate and collaborate, and that we believe that that is the right way to progress into the future. And so for us, there's some real core principles that we live by in the cognitive computing world. So our base purpose is to augment human intelligence. We want to make people smarter. We want to give people tools because, again, people are tool users and tool builders. We want to have transparency about exactly the data that is consumed, who owns that data. Our goal is not to take the data and resell it to someone else. Our goal is to make sure that if you provide data into a cognitive experience, that data remains yours. It's not for us to resell. And we want to make sure with our customers and with our partners that you know who's training the AI, the artificial intelligence, and exactly how it's trained. We believe that this is vital and that all suppliers of this level of technology should do that. And lastly, we have a big job to train people how to use and develop this technology. I think you're seeing a lot of this in the world, but we need to help everyone to up-level their game in the face of this technology. So at the end, we're fascinated to work with you on your cognitive cities, and I thank you very much for your time.
Christian Klaus, ladies and gentlemen. Thank you, sir. We have some time here, so if I may bother you with the, in your presentation you said that the importance of having the computer analytics work in concert with human intuition seems to me to be one of the most important points of building the cognitive cities. So could you dig a bit deeper into that, please?
Sure. So I think that what you see in when we looked at the Lyon Center is those employees are experts in water, right? They've been working for many years in a water operations center. They know how fresh water works. They know how wastewater works. They know what the problems are that can happen in that factory. And basically what we're trying to do is take what they're learning and encode more and more of that into software and be able to do better work, have higher quality water in a repeatable process. And so that interaction between men and machines, people and machines, is super important to what we're doing in that center and in other operation centers. A lot of our work is based on a notion of an operation center, people working across the city from one center and using the machines to do so.
So basically, you have as much trust in humans as you have in the development of technology. I mean, we've all seen how lazy people can become. And isn't there a risk that when you have such developed technical basis for all the operations, that actually the guy who comes to the office is just pushing buttons and forgets his intuition home?
Yeah, I actually have more trust in the humans than I have in the computers at this point. We're very early in this emergence of this technology, and so having humans engaged, having humans involved, having humans understand at a deeper and deeper level is very important. And actually, I find a lot of the workers are committed to do a good job. They've worked for a long time. They value their fellow citizens. They value their work. And so I find as tool users and tool builders, they're excited to engage, to learn a new thing, to think about their work in a different way. No, I think today we need to work in a synergistic way, and that's the way to make this work.
Thank you. Christian Klaus,
Thank you very
hyvät naiset ja
much.
herrat.